Today, we're not just learning about capacitors, we're feeling what happens inside them. So, what's a capacitor? Think of it as a tiny, supercharged battery with two metal plates separated by a small distance. It's neutral overall, but when connected to a battery, things change. Let's talk about the charging of a capacitor. A 9V battery pushes positive charges onto one plate, leaving the other negatively charged. At first, charges move easily, but as they pile up, they resist, building up potential energy. This creates an electric field, opposing further charge flow. The capacitor keeps charging until its voltage matches the battery's. How much energy it stores? The work done to move charges is stored as potential energy. Using integration, we find that energy U equals 1/2 CV square, like compressing a spring of electric charge. How to take that energy back, or discharge the capacitor? Remove the battery, and if we connect a bulb, the stored charge rushes back. The bulb lights up briefly before the capacitor is empty. The charge versus time graph shows a rapid rise when charging and a steep drop when discharging.